Welcome back. Today we're talking about chapter 1.4, angles. Specifically, how can I find and compare measures of angles? Also name them. All right, so there's some little bit of vocab to go over. First off is the vertex of an angle. The vertex of an angle is the tip or part where the angles come together. The point where the sides of an angle come together. It's actually easier to give a definition for vertex angle by just drawing a picture. If that was my angle, that point right here where those sides come together, that's the vertex. All right. Example, how do we use it? We use the vertex angles when we're naming an angle. So there's lots of ways to name an angle. One way is there might just be a number in here. Like if I had this angle here and I put a 1 there, let's add another angle here and add a 2. Then I could say, hey, angle 1 is this one right there, and angle 2 is that one right there. Naming angles by numbers is one of my favorite ways of naming angles. However, I could also, let me do this. Angle 1. You can also name an angle by its letters, by its points, the letters of the points that land on it. So if there's an A here and a B here and a C there, I can name that angle A, B, C. Here's where vertex comes in. If you name an angle by the points that are on it, that middle point there has to always be the vertex of the angle. So A to B to C, where that B is right in the middle. I could have also named it angle CBA, because that B is still in the center. So the way I name angles is either with a little number, if there's a number in the angle, or with its letters. Just make sure that vertex is the middle letter. I could not name this ACB. Hold on, my iPad is being funny. All right, I could not name it angle ACB because ACB would be the one that starts at A, goes to C, and then to B. It would be this angle here. That's not the angle I wanted to refer to. So when naming angles, you either name them with a number, if there's a number in there, or by 3 letters, with that center letter being the vertex. This little tool, you might have seen that before. It's called a protractor. Protractors are how we can measure the degrees of an angle, how wide it opens up. There's the origin. This is where you put the vertex. There's a baseline, that's where you put one of the sides of the angle, and then the other side of the angle will land somewhere on one of these scales. Now those are dual scales on most protractors because it depends on which side you open up from, right? If I'm going from this side that way, start at 0, 10, 20, you start on the outside. However, if I put my angle on this side, 0, 10, 20, and going that way, then I use the inside scale. A couple quick examples, it's not hard. Here I've got an angle, not quite here. This continues like that. Sorry about that. Let's see. All right, I'm just gonna sketch that in. All right, I've got an angle right here. This one is starting here and opening up that way. So I'm gonna start at the 0, 10, 20, 30, 40, right at the 50. This is a 50-degree angle. This angle starts on the other side. I'm gonna add that there. So this one goes from here and opens up that way. So there's 0, I'm gonna start with the 0, the scale on the outside, 0, 10, 20, 30, da, 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 da. Looks like it goes all the way to 130. So it's a 130-degree angle. All right, you might have heard words like acute angle and obtuse angle before. We're gonna review those as well. An acute angle is just an angle less than 90. an angle less than 90 degrees. Just those little acute angles, right? They're called acute angles. Acute means kind of sharp, like little sharp angles. An obtuse angle is more than 90 degrees. An angle more than 90 degrees. But less than 180, which almost all of them are. Oh, right there though, but less than 180 degrees. So obtuse angles, obtuse means kind of blunted. It's not nearly as sharp of a point. Obtuse angles look like this, or those really wide angles. A right angle is an angle that's exactly 90 degrees. So it looks like this. If you have a right angle in a textbook somewhere, again, we want to make sure about not making assumptions. That looks like 90, but what if I say, maybe it's like 89.9 degrees, right? So if you wanted to show a symbol that shows exactly 90, the symbol for that is a little box in the corner, like that. Box means 90 degrees. All right, and the very last one is a straight angle. A straight angle is one that adds up to that, that's 180 degrees. It's exactly 180 degree angles. It's kind of a silly angle to have because really it's an angle that goes like this, right? It's kind of a line, 180 degrees. So if it forms a line, it's a 180 degree angle. One other thing I forgot to mention, so I'm going to mention it off to the side now. Congruents, or congruent angles. Just like segments can be marked with tick marks, congruent angles can be marked with little curves. So you'll notice how, here, I'll just make an example. Let's say I'm going to do two intersecting lines, ones that cross. And we're going to learn this later, but two intersecting lines actually make congruent angles. I'm going to make it really obvious. You notice this angle here and this angle there? They look the same? They actually are the same. The way we show that are actually with those little curves. You put those curves there, it means they're equal. If I wanted to show a different pair were equal, you could do a double arc. That shows those are equal. So arcs show congruence. Another example, if you like, I'll put over here. If I said, if this angle and that angle are equal, you just put a little arc there, that means they're equal. Sometimes people will put a tick mark in the arc. That's just fine too. All right. Some practice problems, make sure we have this down. This one, problem 1. What are two other names for angle 1? Well, angle 1 is right here, so it's this opening here that goes there. So they already used the number for the angle, so I'm going to have to use the letters. So again, just keep the vertex in the center. So I could call it angle JMK. You notice the use of that angle symbol right there. Or I could call it angle KMJ, the other way around. Just fine. Just make sure that M is in the center because that M is the vertex. Identify each angle as acute, right, or obtuse. So angle AOB, A to O to B. This angle has that little box right there, and that little box we learned means 90, so that's a 90 degree angle. 90 degree angles out of these three choices. Remember that one? That's the right angle. Next, it's asking for AOC. That'd be from A to O to C. That's definitely bigger, right? If this was 90, that's more than 90. So one that's more than 90 degrees is obtuse. All right, two more. COB starts at C, goes to O, then up to B. That is definitely less than 90, right? This whole thing here would have been 90. But that's definitely not the whole thing. So that's less than 90, that would be acute. And then the very last one, COD starts at C, goes to O, and then to D. That is also acute. It's not quite a 90, right? 90 would have been all the way to here. That's not quite 90 degrees. All right, we are almost done. DEF is a straight angle. Straight angle, again, we know means it's 180 degrees. What are the measures of DEC and CEF? Well, this looks like an algebra one. I know that all together that's 180. And then they gave me the parts of it. So I know, hey, if I add those two angles together, they should add to 180. So let's write that equation out. I know if I added this angle plus that angle, that should be 180 degrees. So I know 11x minus 12 plus the other one, 2x plus 10. I know that's going to have to equal 180 degrees. We did a problem like this in our last video, right? We had x's on the same side and we could combine them together. That's called combining like terms. So I can combine this 11x and that 2x. That would be 11 plus 2, that's 13 x's. And I can combine this negative 12 and that positive 10. Negative 12 plus a positive 10 is a negative 2, so I'm going to write minus 2. I didn't do anything with that 180 yet, so it's still equal to 180. And then we just do opposite things. The opposite of minusing 2 is adding 2, so I'm going to add 2 to both sides. When I do that, I end up with 13x by itself, because those 2's go away. Again, opposite operations. And that'll equal 182. And then to get rid of that 13, I'm going to have to divide by 13. I'm going to use a calculator for that one. 182 divided by 13 on my calculator. Oh, that says it's 14. It's a better number than I was afraid it would be. X is equal to 14. Excellent. You might have caught on. I didn't answer the question yet. I found X, but it wanted these angle measures. So angle DEC. Angle, let's put them purple here. Angle DEC. That's this one right here, DEC. That's this 11x minus 12. That's 11x minus 12. But now that I know x is 14, I can put 11 times 14 minus 12. And that one I'm just going to put into my calculator. 11 times 14 minus 12 is 142 degrees. All right, the other angle I was asked to find was angle CEF. That's this one right here on the right. So that's 2x plus 10. But again, I now know what x is. X is 14. So I can write 2 times 14 plus 10. That I can do in my head. That's 38 degrees. You will notice when I look at these two, 142 and 38, if I add those together, that adds up to 180. That's good because that's what I was told it was supposed to be. So I'm feeling pretty darn good about those answers. All right, that is it. You get on section 1.4, 7 through 23, the odd numbered problems like 7, 9, 11, 13, and then number 29. Give them a shot. Get in contact with me via Zoom or an email if you're run into a problem you're not sure of. See you later.